Hello everyone, I am Pavitra Devi, working as Assistant Professor in Department of Computer Science, Artificial Intelligence and Data Science in Dr. S.N.S. Rajeshwari College of Arts and Science. Now I am going to take the class about the process synchronization. What is process synchronization? Process synchronization means coordinating the execution of the process such that no two processes access the same shared resources and data. It occurred in a multiple process system where multiple processes are running together and more than one process try to gain access the same shared resources or data at the same time. Changes made in one processor are not reflected when another process accesses the same shared data. It is necessary that the processes are synchronized with each other as it helps avoid the inconsistency of shared data. For example, a process P1 tries to changing the data in a particular memory location. At the same time, another process P2 tries to reading the data from the same memory location. Thus, there is high probability the data being read by the second process is incorrect. On the basis of synchronization, processes are categorized as one of the following two types. First one, independent process. Independent process is nothing but execution of one process does not affect the execution of another process. Next one, cooperative process. Cooperative process is nothing but execution of one process affect the execution of another process. Process synchronization problem arise in the case of cooperative process also because resources are shared in cooperative process. Next one. Next one, sections of the program in operating system. The following four essential program in the sections of program in operating system. First one, entry section. This decide the entry of process. Next one, critical section. This allows the process to enter and modify the shared variables. Third one, exit section. This allows the process waiting in the entry section to enter into the critical section and makes the sure the process is removed through the this section once it's done executing. Fourth one, remainder section. Remainder section is nothing but part of the code. The does not present in the above three section are collectively called the remainder section. Next one, critical section problem in operating system. A segment of code that a signal process can access at the particular point of time is known as critical section. It contains the shared data resources that can be accessed by another process. First one, wait function. Represent the P of 1. Handle the entry section, a process to the critical section. Whereas signal function represented the V handle the exit of the process from the critical section. A single process executes in the critical section at a time. Another process executes after the current process is done executing. Next one, race condition. When more than one process execute the same code, access the same memory, shared variable, it is possible that the output or value of the shared variable is wrong. In this condition, all processors race ahead in a order to prove that their output is correct. This situation is known as race condition. When multiple processes access and manipulate the same data concurrently, the outcome depends on the order in which this process accessed the shared data. When the output of multiple thread execution differ according to the order in which the thread executes, a race condition occurs. We can avoid if the treat as critical section as an atomic instruction and maintain the proper thread synchronization using log or atomic variables. Next one, rules for critical section. There are three rules that need to be enforced in the critical section. There are first one, mutual exclusion. A special type of binary semaphore are used to control access to shared resources. It has priority inheritance mechanism that helps to avoid the extended priority inversion problems. Only one process can execute at a time in the critical section. Second one, progress. We use it when the critical section empty and a process want to enter it. The processor that are not present in the remainder section decided who should go in within the finite time. Third one, bounded waiting. Only specific number of processes are allowed into the critical section. Thus, the process need to make a request when it want to enter the critical section. When the critical section reach its limit, the system allow the process, request and allow into the critical sections. Thank you.